Hello, guys. Welcome to Rumta Solutions. Welcome to your exam prep on forces. So, this is a topic for grade 11 and grade 12 physical sciences. The questions that you see, they are applicable for both grades. Okay, so the question paper that we're looking at today is the Physical Sciences Paper 1 of Gauteng Province that was written in June 2024. Before we get to the questions, let's remind ourselves what the exam instructions are. Remember, all of them are important, but we're going to highlight a few. Instruction 8, you are advised to use the attached data sheets. Instruction 9, show all formulae and substitutions in all calculations. Instruction 10, round off your final numerical answers to a minimum of 2 decimal places. So, what needs to happen here is this: whenever you are making your calculations, in the middle of your calculations, do not round off to 2 decimal places. You can round off to about 4 or 5 decimal places in the middle of your calculations if you don't want to round off at all. Okay? And if you happen to round off, it should be, if you happen to round off to 2 decimal places, it should only be for your final numerical answers. Okay? Instruction 11, give brief motivations, discussions, and so on where required. This is important. So try to explain, in your explanation, try to be brief. Make sense as well, but make sense. Just make sure you get your marks, okay? Instruction 12, write neatly and legibly. I know the neatly part is subjective, but please let's improve our handwriting so that um, our writing is legible. Okay. All right. Now let's get to our question. This will probably be question 3. So let's see. Yeah, it's question 3. So this is question 3. Let's see how much time we need to spend on this question. We need to spend about 22 minutes. Okay. Let's go now. A 5 kilogram trolley is addressed on a rough, that means you're expecting friction, on a rough inclined surface which makes an angle of 30 degrees with the horizontal. A constant force is applied, causing the trolley to accelerate up the incline for 2 meters at 0.45 meters per square second. Ignore the rotational effects of the wheels and air friction. Okay, cool. 3.1 state Newton's second law of motion in words. When a net force acts on an object, and the object will accelerate in the direction of the net force. Okay? Okay, in the direction of the net force. Okay. We are not done, but we are not done. Now, we then say the acceleration is directly proportional to the net force and inversely proportional to the mass of the object. All right? Directly proportional to the net force and inversely proportional to the mass of the object. To the mass of the object. Right? Good. Moving on. Draw 3.2. Draw a labeled free body diagram of showing all the forces acting on the trolley as it moves up the incline. You can use I prefer this one that says up the incline you have the force, you have the normal, okay, and you have the perpendicular component of gravity. This is the applied, and then it experiences gravity. It will also experience the parallel component of gravity. Or if you like, you can also draw it in this way. Say this is your gravity, and then this is your applied force, this is your friction, this is your normal. Okay, perfect. So this is your 5 marks, isn't it? This is your 5 marks, right? Perfect. Oops, what did I do now? Okay, we're done. Oh, is it 5? No, 3 marks. So we good. 3 marks, we good. All right. So remember, I added friction because they said on a rough incline. So this means you are expecting friction. Okay, perfect. 3.3. If the coefficient of kinetic friction along the incline mu sub k is 0.18, calculate the frictional force of the trolley as it moves up the slope. So we know that frictional force, kinetic, not static, kinetic frictional force will be equal to coefficient of kinetic friction multiplied by the normal force. Now this normal force is basically equal to FGY, which is mg cos theta. Okay, so what is it? This is 0.18 times, they said the object is 5 kilograms. 5 times 9.8 times cos 30 degrees. So let's see, right? So let's see, 0.18 times 5 times 9.8 times cos 30 degrees. So the reason I'm not explaining this cos 30 mg cos 30 part is because um this is the 4th video, and in all the 3 videos I have been showing you how we get this. So right now you are used to it, but in case you are not used to it, I want you to imagine it in this way. Let me show you. Let's say now this is your gravity. Okay, this is your theta, which is the angle between the ground and the surface, and then this is your f sub gx. Of course, this is your f sub gy. So what do you have? You have your f sub gy. As you can see, it is it is opposite, it is adjacent to the angle, so we can say cos theta equals f sub gy over f. So we can say f sub gy is basically equal to f cos theta. Sorry, f sub g. Alright, f sub g. Alright, f sub g. So we know f sub g is mg. Okay, so this is how we do it. So let's see now. Our answer is 7.64 newtons. Okay, for how many marks? For 3 marks. Okay, perfect. 3.3.1. Now 3.3.2, calculate the applied force. So when you look at this free body diagram, we will say F net again. Oh my. F net equals MA. So applied force is going up, friction is going in the opposite direction. So is mg sine theta, so equals MA. The mg sine theta is the horizontal component of gravity. As you can see, it's opposite the angle. So it's like saying sine theta equals f sub gx over f sub g. And that means f sub gx equals f sub g sine theta. Okay, perfect. Now, let's proceed. Do we know the value of, oh, we're looking for the value of the applied force. So we know it. The friction was 7.64, and this guy is 5 times 9.8 times sine 30 degrees equals, what is it? Was it, do we have its acceleration? I think we did. 5 We had its acceleration 0.45. 0.45, right? Perfect. So if you like, guys, you can just find your answer, okay? Or you can just do it slowly, but I prefer that you find your answer. Minus 7.64 minus 5 times, 5 times 9.8. 5 times 9.8. In fact, I should say 2.5 times 9.8. So this is 24.5. This is 24.5 equals 135. So it's 1,35, isn't it? 5 times 0,45. It's, oh, 45.90. Oh, really? Come on, buddy. 2,2,25, not 1. 2,25, yeah, that's correct. 2,25, right? Because 0,45 times 4 is 1.8, so that's correct. 2,25, okay? So, so let's see. 2,25 plus 7,64 plus 24,5. What do we get? We get that the applied force was 34,39 newtons. Happy? Perfect. 34,39 newtons. Perfect. Now 3.4, this is interesting, and I'm going to show you. Remember, our object was at an incline. Normal force was equal to F sub gy, which is equal to mg cos theta. So I want to show you cosine graph. Okay, I want to show you cosine graph. This is cosine graph 90, 180. Maybe let me draw it bigger. So your cosine graph, this is 90. It's like this. So this is 90, 180, 270, and then 360. However, we're going to focus on this portion here to 90 degrees, right? So I want you to see here, this is 0. I want you to see as you move from 0 to 90, meaning as your angle increases, what's happening to your curve? It is decreasing, isn't it? So our answer, will the frictional force between, and by the way, having said that, I want also to add this frictional force is equal to coefficient multiplied by normal force. Do you see this? So this therefore means frictional force is directly proportional to normal. Okay, now let's answer the question. The question is, will the frictional force between the trolley and the surface increase, decrease, or remain the same if the angle between the horizontal and the incline increases? So if the angle increases, as you can see, if the angle increases, it means the cos theta part will be decreasing. Therefore, your answer will be decreasing. They say decrease. Why? As the angle increases, as the angle increases, the normal force decreases, right? The normal force decreases, right? The normal force decreases. Oops, decreases. And then normal force is directly proportional to the frictional force. Therefore, frictional force will decrease. Will decrease because it is directly proportional. You see here, I said normal is directly proportional. You can write it in where it's okay. All right. And this is how you get your marks. All right. Perfect. Now 3.5, let's see. 3.5, a spaceship with a mass 100 kilograms, that's a ton, is moving in an orbit 100 kilometers above the Earth's surface. State Newton's law of universal gravitation in weights. So this one we say every body or every particle, but I prefer to use every body everybody in the universe attracts every other body with a gravitational force that is directly proportional, gravitational force that is directly proportional to the product of their masses, to the product of their masses, and inversely proportional to the square of the distance between their centers, of the distance between their centers. Okay. Perfect. So this is 3.5.1. Okay. Perfect. 3.5.2, calculate the magnitude of the gravitational force that the spaceship will experience. It will be F equals universal gravitation constant, mass of the spaceship, and mass of F over the square of the distance between them. So what is the universal gravitation constant? 6,67 times 10 to the negative 11. Mass of the spaceship is a ton, which is 1,000 kilograms. And the mass of Earth is 5.98 times 10 to the 24. We will confirm this. Now they said the spaceship is moving in an orbit 100 kilometers above the Earth's surface. So 100 kilometers, we can say kilo means 10 to the 3, above the Earth's surface. So we can say plus what? Plus 6.38 times 10 to the 6. This is the radius of the Earth. Okay? This is the radius of the Earth. Remember, the spaceship with a mass of whatever 100 kilograms is moving in an orbit 100 kilometers above the Earth's surface. 100 kilometers above the Earth's surface. Okay? All right. So let's see. This is 6,67 times 10 to the negative 11 multiplied by grand 1,000 multiplied by 5.98 times 10 to the 24 over 100 times 10 to the 3 plus 6.38 times 10 to the 6 close square. Now I want to show you guys that in case you are wondering what has happened, okay? In case you are wondering what has happened, where do we get these values? 5.98 and 6.36. We're gonna get them in our formula sheet or our data sheet. The mass of Earth, here is it. The mass of Earth is 5.98 times 10 to the 24 kilograms. Do you see it? This is the mass of Earth. And then the radius of Earth is 6,38 times 10 to the 6. And here is it. Okay? All right. Okay. So having said that, you then get your answer. What is your answer? Your answer is 9,768.44 newtons. This is the gravitational force that the spaceship will experience. Okay, this is the gravitational force that the spaceship will experience. All right, so we have come to the end of our service, of our video. And remember, guys, before I conclude this, remember this portion. The radius I have added it because the definition or the law says the square of the distance between their centers. This center we're looking at for big objects, we're gonna look at their centers. So a F is a very big object, hence we're going to look for its center, its radius. Okay, so of course the spaceship it's not that big, that's why we don't even consider its center. Okay, so this is how you answer these questions. Remember, if you would like to follow us, there's a link in the description of this video where you can follow us on your WhatsApp. We have a WhatsApp channel. We just launched it. We have a WhatsApp channel. We have all your social media platforms, your Facebook, Twitter, Instagram. You can follow us there. And of course, if you're looking for a tutor, you can also um check our website. And because you're watching on YouTube, please subscribe. And if this was very beneficial to you, please like and share with your friends. With that being said, it's a wrap and bye bye.